Welcome to HI, Global New Military Updates. This is where we update military developments, global strategy, and the power of modern weapons with a deep and emotional personal perspective. Each video is a beat of the times. Together, we analyze and reflect on power, war, and peace in a turbulent world. Ladies and gentlemen, do not take your eyes off the screen, and do not forget to subscribe to the channel, as well as leave a comment below. In 1962, President John F. Kennedy shocked the world when he declared at Rice University,
"We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard."
That statement became a symbol of the American conquering spirit, daring to set goals that seemed impossible and determined to achieve them. More than 65 years later, the name John F. Kennedy is once again mentioned in another monumental project, the USS John F. Kennedy, CVN-79. A new generation nuclear supercarrier of the U.S. Navy, the second in the Ford class. This is not only a giant warship worth over $13 billion, but also a symbol of America's ambition to maintain naval supremacy throughout the 21st century. What truly captures global military attention is not just the 100,000-ton size or the modern EMALS electromagnetic launch technology, but a much bolder question. Could the USS John F. Kennedy be the first aircraft carrier designed with the potential to operate sixth-generation fighters in the future? While countries like China and Russia are pouring resources into developing hypersonic missiles and stealth UAVs, the United States is betting on the combination of the Ford-class supercarrier and the sixth-generation fighter program. If Kennedy can actually deploy this new aircraft, it will become a strategic springboard for America to maintain dominance of the skies and the seas. Aircraft carriers and their historic role. Over the past century, no weapon has shaped naval warfare as much as the aircraft carrier. Since Japan launched the Hosho in 1922, the world's first dedicated aircraft carrier, the very nature of naval warfare changed completely. During World War II, aircraft carriers quickly surpassed battleships to become the decisive weapon. At the Battle of Midway in 1942, within just a few days, 4 Japanese carriers were sunk, turning the tide in the Pacific. Since then, aircraft carriers have become the centerpiece of American global power. During the Cold War, they served as deterrent tools, present at every hotspot from Europe, the Middle East, to the Asia-Pacific. After the Cold War, they continued to play a spearhead role in campaigns from the Gulf to Afghanistan. It is no coincidence that every time an international crisis broke out, the familiar question remained: where is the nearest U.S. aircraft carrier? The key factor that allowed carriers to maintain their power for decades was their ability to adapt to changes in naval aviation. Each era, they were designed to match the dominant aircraft of the time. 1940s, carriers only needed to carry propeller aircraft. 1960s, the flight deck had to be strong enough for the F-4 Phantom jets. 1980s, the Nimitz class was optimized for the F-14 Tomcat, and later the F/A-18 Hornet. Early 21st century, the Ford class appeared to prepare for the F-35C Lightning II, America's first carrier-based stealth fighter, while also paving the way for UAVs and future generations of aircraft. Since the first Nimitz-class carrier entered service in 1975, these giant mobile air bases have become a symbol of U.S. naval power. With a displacement of 100,000 tons and the ability to carry up to 90 aircraft, the Nimitz class dominated for nearly half a century. But by the 21st century, limitations became clear. Enormous operating costs for nearly 5,000 sailors. Steam catapult system. Bulky, wearing out aircraft. Insufficient electrical power for integrating new technologies. In response, the U.S. Navy developed the Ford-class nuclear carriers. The first, USS Gerald R. Ford CVN-78, began construction in 2009, launched in 2013, and commissioned in 2017 at a cost of $12.8 billion to build, plus $4.7 billion in research and development. This was the most expensive warship ever built at that time. The Ford class introduced a series of breakthrough innovations. Equipped with two A-1B nuclear reactors, providing far greater power than the Nimitz class. Electromagnetic Aircraft Launch System, EMALS, replacing steam catapults, smoother operation, less airframe wear. Sortie rate increased by about 30%. Advanced Arresting Gear, AAG, for flexible recovery of UAVs and heavy fighters. Electromagnetic Weapon Elevators, speeding up rearming. Dual Band Radar, DBR, combining X-band and S-band. Higher automation, reducing the crew to approximately 4,600. These upgrades proved that the Ford class was not just an evolution, but a revolutionary step, laying the foundation for the next decades of U.S. carrier dominance. Upgrades on USS John F. Kennedy, CVN-79. Developed on the Ford-class platform, but Kennedy introduces major changes in tonnage and dimensions. While Ford's full displacement is about 100,000 tons, Kennedy is said to increase by 12,000 to 20,000 tons. This allows carrying more fuel, ammunition, spare parts, and extending continuous sea operations without resupply. Kennedy's length remains 337 meters, but its width has increased to 79 meters, 1 meter wider than Ford. A small number on paper, but with big meaning. Wider flight deck, more parking space, takeoff and landing less congested, smoother coordination. Maintenance, refueling, and rearming made faster. At the heart of Kennedy lies the A-1B nuclear propulsion system, a breakthrough improvement over the Nimitz-class A-4W reactor. Nimitz generates about 550 megawatts, while Kennedy's twin A-1B reactors produce up to 700 megawatts, a 25% increase. The ship can sustain speeds of over 30 knots for long periods, while powering all combat systems. A-1B offers 30% higher thermal efficiency, 25% smaller size, and nearly 20% lighter weight. This frees up space inside the hull, adding storage, technical areas, and auxiliary systems. Another major advantage, refueling cycle lasts up to 25 years, nearly the ship's lifetime. This significantly reduces operating costs and time spent in maintenance. The massive power from A-1B also supports cutting-edge technologies such as EMALS, Electromagnetic Launch System, AAG, Advanced Arresting Gear, High-Power Phased Array Radars, Directed Energy Weapons, Lasers. Kennedy is not just an aircraft carrier, but a true mobile power station, ready for 21st century naval warfare. One of the revolutionary improvements on USS John F. Kennedy, EMALS on Kennedy, EMALS, Electromagnetic Aircraft Launch System, completely replaces the steam catapult system that existed for more than half a century. Instead of using steam pressure, EMALS operates with a linear induction motor, generating extremely strong electromagnetic force to accelerate an aircraft from standstill to takeoff speed in seconds. Compared with steam catapults, EMALS offers three major advantages. 1. Eliminates bulky boilers, freeing weight and space. 2. Smoother acceleration, reducing airframe wear. 3. Increases sortie rate by about 30% compared with Nimitz class. This is a decisive factor in high-intensity campaigns. However, on USS Gerald R. Ford, EMALS faced many issues, with reliability lower than design expectations. Reports showing incidents after just a few dozen launches. This led to heavy criticism in the early phase. On Kennedy, The system has been fine-tuned with lessons learned. Improved material durability, enhanced control software, adjusting launch force for each aircraft type. Alongside IMLS is AAG, Advanced Arresting Gear, an electromagnetic arresting system replacing traditional hydraulics. The old system was stable but inflexible, struggling with widely varying aircraft weights. AAG adjusts braking force by scenario, preventing light UAVs from abrupt stops while safely handling heavy fighters. During tests, AAG also faced reliability problems, but on Kennedy, further optimizations aim to enhance durability and smarter electronic controls. If successful, the combination of IMLS plus AAG will mark a comprehensive leap: safer launches and recoveries, more efficient operations, less wear and tear. This is the core change that enables Kennedy to sustain high operational tempo, ready for multiple types of aircraft. A notable improvement on USS John F. Kennedy, the AWE, Advanced Weapons Elevator System. AWE replaces the traditional hydraulic elevators used on the Nimitz-class carriers. While the old lifts were stable, they were also slow, often creating bottlenecks during high-intensity combat operations. AWE, on the other hand, is designed with electromagnetic motors, capable of moving bombs, missiles, and ammunition much faster from the storage bays up to the flight deck. However, on USS Gerald R. Ford, this system became a serious issue. Software glitches and integration problems plagued the elevators. At times, only 2 out of 11 elevators were operational, severely limiting the squadron's ability to rearm during combat missions. For USS John F. Kennedy, the U.S. Navy expects these flaws to be overcome. Elevator structures have been reinforced, the control systems optimized, and the entire design integrated from the very beginning instead of being added later as retrofits. According to technical analysis, the elevators can reach speeds of 150 feet per minute, with a maximum load of nearly 24,000 pounds, enough to handle almost all modern weapon systems in just a few minutes. If successful, Kennedy will maintain a much higher sortie rate, allowing carrier-based aviation to operate continuously and efficiently, instead of being constrained as before. This improvement clearly reflects a new U.S. Navy design philosophy, not only emphasizing survivability and defensive power, but also focusing on rapid combat turnaround, high rearming efficiency, and achieving a decisive advantage in modern warfare scenarios. Radar and surveillance technology on USS John F. Kennedy. Initially, the Ford-class carriers were equipped with the dual-band radar DBR, a combination of the X-band SPY-3 and the S-band SPY-4 radars. This system was expected to deliver comprehensive surveillance capabilities, detecting multiple types of targets and enhancing combat control. However, DBR soon revealed significant drawbacks. Its development costs were extremely high, and its architecture was complex and difficult to maintain. Because of this, the U.S. Navy shifted direction. On USS John F. Kennedy CVN-79, DBR was replaced by the EASR Enterprise Air Surveillance Radar. EASR features a modular design, costing about $350 million less than DBR, and it is much easier to integrate across various platforms, from destroyers and amphibious ships to aircraft carriers. Despite being cheaper, EASR still provides long-range detection, multi-target tracking, and greater reliability. The greatest strength of EASR lies in its multi-platform data connectivity. Instead of operating as a standalone system, it can link directly with satellites, airborne early warning aircraft, reconnaissance UAVs, and escort ships, creating a comprehensive battlefield picture that allows Kennedy to detect, classify, and track threats from multiple directions simultaneously. This decision reflects the U.S. Navy's new philosophy, not necessarily choosing the most expensive technology, but prioritizing effective solutions that are easier to maintain and can be deployed across the entire fleet consistently for decades to come. Carrier Air Wing on USS John F. Kennedy. The strength of an aircraft carrier lies not only in its size or propulsion system, but most importantly in the carrier air wing it carries. On USS John F. Kennedy's CVN-79, all improvements in deck layout, elevators, EMALS, and radar serve one ultimate goal: to deploy a diverse, flexible, and superior combat-ready air wing. By design, Kennedy can carry up to 100 aircraft of various types, more than USS Gerald R. Ford, which typically maintains around 75 to 90 aircraft. This increase comes from a larger deck area, more efficient coordination, and upgraded weapons elevators that allow faster and synchronized rearming for multiple aircraft at once. However, more important than the absolute number is the squadron composition. The main force on Kennedy will be the F-35C Lightning II, a fifth-generation stealth fighter specifically designed for carrier operations, with advanced stealth features, state-of-the-art electronic systems, and the ability to share combat data seamlessly. The F-35C is considered the trump card, enabling carrier strike groups to attack heavily defended areas. Alongside it, the F/A-18EF Super Hornet continues to serve as the backbone of U.S. naval aviation. Though lacking stealth, the Super Hornet is valued for its multi-role capability, high reliability, and adaptability to diverse combat scenarios. Supporting them is the EA-18G Growler, a specialized electronic warfare variant tasked with radar jamming, suppressing enemy air defenses, and shielding the entire fleet as it penetrates deep into hostile airspace, ensuring early warning and logistics capability. To maintain air superiority, Kennedy will operate the E-2D Hawkeye, an airborne command and control aircraft with a powerful AESA radar, capable of tracking hundreds of targets simultaneously and providing data for the entire fleet. In the logistics and resupply role, the U.S. Navy is transitioning from the C-2 Greyhound to the CMV-22B Osprey, offering more flexible transport capability and enhancing resupply effectiveness under diverse combat conditions. For anti-submarine warfare and maritime patrol, the MH-60R/S Seahawk continues to prove its versatility and effectiveness in missions ranging from anti-submarine hunting, search and rescue, to naval combat support. The most remarkable highlight is that Kennedy will be among the first carriers designed to operate the MQ-25 Stingray, an aerial refueling UAV. This is considered a game-changer, as it significantly extends the combat radius of the F-35C and Super Hornet, which are often limited by fuel capacity. With the MQ-25, carrier strike squadrons can operate hundreds of kilometers further, expanding their control area and boosting the strategic strike capabilities of the entire carrier group. Beyond that, Kennedy could also serve as a platform for testing and deploying new combat UAVs, continuing projects like the X-47B, which had been previously tested. Weapons and defense of USS John F. Kennedy. A supercarrier is not only a platform to deploy squadrons, but also a top strategic target in any conflict. Therefore, Kennedy's defense is designed to be multi-layered, countering threats from hypersonic ballistic missiles to low-cost suicide UAVs. In the outermost protective ring, Kennedy is equipped with Evolution Spiral missiles with 2 launchers, capable of intercepting high-speed cruise missiles and enemy aircraft at medium range. Closer in is the Rolling Airframe Missile, RAM, with 2 launchers, specialized in handling close-in threats with lightning-fast reaction. If a threat penetrates both outer layers, the final line of defense is the Phalanx CIWS, a 6-barrel Gatling gun capable of firing thousands of rounds per minute, creating a steel shield to destroy missiles or UAVs at short range. In addition, Kennedy is armed with 4 Mk-38 25mm cannons and 4 M2 Browning .50 caliber heavy machine guns designed to counter fast attack boats, small targets, or mini UAVs. Thanks to this combination, the ship possesses a layered shield from long range to close in, protecting not only itself, but the entire air wing on board. The technological highlight lies in the integration of directed energy weapons, notably the Helios laser system developed by Lockheed Martin. In recent tests, Helios demonstrated its ability to shoot down UAVs and neutralize rockets, opening a new path for fleet defense. The strength of lasers is their extremely low cost per shot, capable of firing continuously as long as there is sufficient power. With abundant energy from the 2A-1B reactors, Kennedy can fully operate high-intensity laser systems, something previous carrier classes could not achieve. Sixth-generation aircraft and the future of Kennedy. As early as the 1990s, the U.S. began researching technologies for the next generation of fighter aircraft, laying the foundation for the NGAD program. By 2007, the program was officially launched, and to date it has achieved significant milestones. A full-scale prototype has already been built and flight tested, showing that the U.S. is getting closer to real deployment. The sixth-generation fighter is expected to surpass the F-35C Lightning II in many aspects. More advanced stealth capability, stronger sensors, integration of artificial intelligence to support pilots, ability to operate with UAV escorts, longer combat range. Most importantly, they are designed to counter dense air defense systems that previous generations could hardly penetrate. The big question is, will the USS John F. Kennedy be ready to host these future aircraft? Technically, the carrier has many suitable platforms. EMALs can adjust launch power, enabling safe takeoff for both light UAVs and heavy fighters weighing tens of tons. AAG provides flexible arresting capability, effectively absorbing energy for aircraft with different speeds and weights. The A-1B reactors provide massive electrical power, sufficient to operate the advanced electronic systems carried by sixth-generation fighters. However, deploying these aircraft is not just about takeoff and landing. It also involves logistics and onboard infrastructure. Hangars must be large enough to house bigger aircraft. Maintenance stations require specialized equipment. Technical crews must be retrained. Spare parts storage, fuel, and supply systems must also be adapted for long-duration combat. If these challenges are overcome, Kennedy could become one of the world's first carriers to operate sixth-generation fighters, elevating U.S. naval air power to a whole new level. New challenges for the supercarrier. Despite having the most advanced technology, the USS John F. Kennedy and the Ford-class carriers still face major challenges. For decades, U.S. carriers were considered virtually invulnerable, but now that is changing. The biggest threats come from anti-ship ballistic missiles, hypersonic missiles. China fields the DF-21D and DF-26 with ranges of thousands of kilometers. Russia has tested missiles reaching Mach 8 speeds, extremely hard to intercept. Just one such weapon could threaten an entire carrier strike group. At the same time, cheap suicide UAVs and swarm tactics are emerging. Hundreds of small drones could overwhelm multi-layered defenses, making the risk of saturation ever present. In addition, global satellite surveillance makes it harder to conceal carrier positions, undermining stealth and maneuver strategies. Another critical factor, cost. Each ship costs about $13 billion. Annual operating expenses run into the billions of dollars. This is an enormous investment. If Kennedy were taken out of action, the loss would not only be military, but also a political and financial shock to the U.S. Even so, the U.S. Navy still views carriers as strategic centerpieces. With the ability to integrate UAVs, sixth-generation fighters, and directed energy weapons, Kennedy is not only a target to defend, but also a deterrent and a symbol of power. The future of the supercarrier Kennedy. The greatest challenge lies in one question. Can the U.S. maintain its doctrinal advantage and deployment capability, turning these mobile fortresses into true strategic assets for the next half-century? The question posed from the very beginning remains: will a supercarrier like the Kennedy be strong enough to adapt to an era of hypersonic missiles, drone swarms, and global satellite surveillance? And more importantly, can it become the foundation for operating sixth-generation fighters? The answer can only be determined in the coming decades. If Kennedy can combine traditional power with future breakthroughs, it will not only be the successor of the Ford class, but also a leap forward, pushing the U.S. Navy deeper into a new era of naval warfare. Once operational, Kennedy will serve as a living test for America's claim as the King of the Seas. Will that title remain intact, or must it be shared with new platforms of the 21st century? The USS John F. Kennedy supercarrier is not just a massive block of steel worth tens of billions, but also a strategic message. True power endures only when tied to the ability to constantly innovate. If Kennedy succeeds, it will stand as a symbol of determination to conquer the future, just as President John F. Kennedy once spoke of the moon. A strategic message from the Kennedy supercarrier. The USS John F. Kennedy supercarrier is not only a massive block of steel worth tens of billions of dollars, but also a strategic message sent to the world. Throughout the past century, aircraft carriers have reshaped naval warfare many times, from World War II to the Cold War, and now the era of UAVs, artificial intelligence, and hypersonic missiles. The United States still chooses to lead the way. They bet on goals that seem impossible, but it is precisely that courage that has turned dreams into real power. The question we must ask: can the Kennedy help the U.S. maintain its throne of the seas in the 21st century? Or will that power have to be shared with rising challengers? One thing is certain: power is not only about scale, but about the ability to constantly innovate. Because true power never comes from copying, but from daring to try, daring to fail, and rising again to create breakthroughs. If the Kennedy succeeds, it will stand as a symbol of determination to conquer the future. Just as John F. Kennedy once declared about the moon, "We choose to go to the moon, not because it is easy, but because it is hard." Aircraft carriers, a symbol of power and a lesson for the future. When the USS John F. Kennedy officially enters service, it will become a living test for America's position as the King of the Seas. Will the U.S. keep that title intact or share it with the new power platforms of the 21st century? The most important lesson Kennedy demonstrates is not only in scale or advanced technology, but in a strategic law. Lasting power always comes from continuous innovation. Russia retains its own advantages, but pays the price of technological limitations. China may copy, but copying can never surpass true creation. Meanwhile, the U.S. continues to choose the harder path: to lead, to dare, to fail, and from failure to leap forward. The Kennedy is not just a ship. It is a strategic symbol, a reminder that in a turbulent world, only those who dare to lead can truly hold power. And the final question for us: is it not human will and wisdom that form the ultimate weapon, more than steel, fire, or technology? Aircraft carriers, a symbol of power and a lesson for the future. When the USS John F. Kennedy officially enters service, it will become a living test for America's position as the King of the Seas. Will the U.S. keep that title intact or share it with the new power platforms of the 21st century? The most important lesson Kennedy demonstrates is not only in scale or advanced technology, but in a strategic law. Lasting power always comes from continuous innovation. Russia retains its own advantages, but pays the price of technological limitations. China may copy, but copying can never surpass true creation. Meanwhile, the U.S. continues to choose the harder path: to lead, to dare, to fail, and from failure to leap forward. The Kennedy is not just a ship. It is a strategic symbol, a reminder that in a turbulent world, Only those who dare to lead can truly hold power.
The final lesson: where does true power lie?
The supercarrier USS John F. Kennedy is not just a massive block of steel worth tens of billions of dollars, but also a strategic message. Power does not only reside in size, but in the ability to constantly innovate. For over a century, aircraft carriers have reshaped naval warfare, from World War II to the Cold War, and now the era of UAVs, hypersonic missiles, and artificial intelligence. America still chooses to lead, to bet on what seems impossible, because true power does not come from copying. It comes from daring to try, daring to fail, and then rising to create a new leap forward. The big question remains: will the USS John F. Kennedy be strong enough to keep America's throne over the oceans in the 21st century? The answer can only be proven by time and the battlefield. If you found this video valuable, please subscribe, turn on the notification bell, and share your thoughts in the comments below. This is Hi. See you in the next video.